So hi everybody. Today we are on the week. This is the second video for the week beginning on August the 4th. Today is Thursday. The deadline for submissions is tomorrow. So I can see this is module 5. So we already have several submissions. They all seem good. I already said this a couple of times. This .txt is not what is being asked, so this would be an incorrect submission if maintained, and the person can always resubmit the correct file. So it needs to be a .prj file, .png file, and the commentary. Most people do it correctly, but this is not a correct submission, this one here. So this is due by 1 p.m. tomorrow. Those who submitted correctly, well done. Thank you very much. Today I wanted to talk about what I discussed before, which is doing nonlinear analysis. And this is something that is important because nonlinearity exists. In fact, most relationships are nonlinear. But if they are not nonlinear, changing the analysis to nonlinear would give you biased results. So to demonstrate this, I created a data set and I conducted an analysis and I created the data as linear. Okay, so I created this data set using Excel. Normally I use a more sophisticated method called Monte Carlo method, but this one I created with Excel. Two variables y and x linearly related, and in fact I have the Excel here, and I would use a formula like this to create the data set. So there's always an error term that's here. Otherwise, the relationship would have a correlation of 1. So this is a linear relationship. So I have a number multiplied by x, and that's the value of y that I'm creating, plus a number multiplied by an error term. And so that gives me a relationship. For a nonlinear relationship, I would have something like this: a number multiplied by, say, x squared plus a number multiplied by the error term. So there's always an error term. And the x squared here would be leading to a nonlinear relationship of the warp 2 type. That would be a quadratic relationship. So in this particular file, in this particular project, I created a nonlinear relationship. We can see the graph, and we can see the graph with data points. And I created on 1 to 7 scales both variables, right? So this is a linear relationship. It's significant association, and I have 50 data points. Now, if I were to go to settings and change this relationship to say warp 2, that's a nonlinear relationship, I would get a coefficient that is different from the true coefficient. The true coefficient here is for the linear relationship is 0.35. This one is 0.37. So by setting the relationship as nonlinear, I am having the software overestimate the association by a little bit. And what the software is doing here is actually modeling error as part of the relationship. That's the problem. So, and this problem becomes more severe as the sample size goes down. So this is why I'm asking you to make sure that you set your settings to linear, the default intermodal analysis algorithm as linear, so that all of the analysis you're conducting are linear analysis. Because to do a nonlinear analysis, you have to have the expectation that the relationship is nonlinear. Now, you may ask, what if I suspect that the relationship is nonlinear? What do I have to do to check whether the relationship is truly nonlinear and then do a nonlinear analysis? So I discussed this. This is not for the class, just an extra, but I discussed this in this paper here. Moderated mediation and J-curve emergence in path models. And often moderation, like you've seen in the assignment for Module 5, induces nonlinearity. In fact, moderation is a type of nonlinearity. So in this paper, so if you click here, you get this paper, and then on the third page of this paper, you see this relationship. And when you look at this, right, so let's say I did not have the curve passing through the points. If you're looking only at the points, you would suspect that this is a relationship. And in fact, there is a test that is, so the paper talks about a lot of things in detail, but there is a test, which is this segmentation delta test, which again is not something that you need to do for this class, but if you're curious, you can read this paper, and this is a method that allows you to find out whether a relationship is linear or nonlinear. And then you set the algorithm as nonlinear, and you conduct the analysis. So warp 2 would be for J-curve types of relationships like this one, and warp 3 would be for S-type relationships, which are more consistent with logistic regression and other types of analysis, and they're not being covered in this course. It would require another course to cover them. So that's all I have for this video. Keep up with the good work. The class is doing very well. Most students are completing all of the assignments. I did have a question that came through a message from a student. That was a question that I cannot answer here to the whole class because it was a private question. But I can see that there are no generic questions, which would be under here, Module 1, Course Overview. And the question that came from the student, I responded already, so I hope the student got my response or will get soon. So that's all I have for today. Thank you very much, and have a good remainder of the week and the weekend. And I'll see you again next week.